You want to keep it personal.
I think Baby Yoda's like 500 years old or something.
Damn, what the hell?
Yeah,
Really?
it's like the way the age is different.
That can't be right.
Here's backwards.
Fucking Benjamin Button. Alright. So, we were working on 1.6. So this would be like 1.6b. And we were doing like other types of equations. We did rational equations. I'm not gonna do more of those because we need to keep going. But we did like one example with equations that looked quadratic. So for example, the one we did before, I'm not gonna redo. But we did x minus 3 to the 1/2 minus 6 times x minus 3 to the 1/4 minus or plus 8 equals 0. And the key takeaway, the key thing to look for, if this is not a 2 and this is not a 1 or like doesn't show up, is this double that 1/2 does equal 2 times 1/4. So we could write them as a quadratic equation. And the way you did that is you set the smaller thing complete with the exponent equal to u. So that u squared equals x minus 3 to the 1/2. We did that. That should be in your notes. Let's advance it to another type of one. Same idea, not quadratic, but we can make it look like it. Now to start off, we want to get everything on the same side. So we would subtract 3 to both sides.
You're subtracting 3 from the 4x or
From the left side in general.
okay.
The 4x has an x in it and
Yeah.
3 doesn't, so I can't combine. But I can put them on the same
I
side.
thought you were doing it direct with
So what now?
I thought you were just subtracting negative or 3 from the negative exponent.
Oh, no.
Sorry.
So like this isn't a positive 2 and this isn't a positive 1, but negative 2 is 2 times negative 1. So I can say u equals x to the negative 1. And if I square this, u squared equals x to the negative 2. Because if I square x to the negative 1, we multiply the exponents. And we get that. Which means I can rewrite this as 15u squared minus 4u minus 3 equals 0. Nah, try to factor it. I think it might factor. A times C is negative 45 and B is negative 4. Two numbers that add to negative 4 but multiply to negative 45. The bigger number's got to be negative. I can try 1 and negative 45. That doesn't work. 3 and -15 doesn't work. 5 and 9, -9. That gets me -4, that works. So I can rewrite this as 15u squared, and I have the -3. 5 and the -9 come from that. Plus 5u minus 9u. So if I group them, I can pull out a 5u there, and I have 3u plus 1. And I should get another 3u plus 1 on the other one. If I factor out a -3, I will. So we're just factoring pairs. So we finished factoring. This is 5u minus 3 times 3u plus 1 equals 0. So we set each of these equal to 0 by the 0 product rule. And if we solve, I add 3 to both sides there, I get 5u equals 3. So u equals 3/5. I can subtract 1 on this one from both sides and then divide by 3. Okay, so we didn't start with u, so we can't end with u. U was x to the -1. Which really means 1 over x. We put it on bottom. With make the exponent positive. An interesting thing, you could see if you did the like cross multiplying. Would get us 3x equals 5. And then we divide both sides by 3 and we get x equals 5/3. I started with 3/5 equals 1 over x. And I ended with x equals 5/3. When you want to get something on the bottom on top, you can just flip it. 5 over 3 equals x over 1. That does that. So here I can just flip this. If I flip this, this is x over 1 and this is -3 over 1. So x equals -3. Or x equals 5/3. Right? Here looks like a deer in headlights right now.
Well, just soaking it in.
I think I will write these notes down later. Okay. So I'm not gonna solve it, but I wanted to see, like, have you guys help me, like. What's the first step of this one? I have 18x to the fourth minus 29x squared plus 3 equals 0. What would be my first step here?
Subtracting 3 from both sides.
Why?
It's already equal to.
We want to equal 0. He's got a good point. Now, if we were gonna try to complete the square, we could, but
You gotta find a, what? Multiply us to 18 and 3x to make it.
Substitute the x to the 4.
we want to address this. They're not right. Josue's got, you got the second step. You were like, let's factor.
Yeah,
You can factor this when you're skilled enough, you don't need to make this substitution first. But we don't have x's. We have x squared here, and this is x to the fourth, but 4 equals 2 times 2. So if I say u equals x squared, when I square both sides here, I get u squared equals x to the fourth. And that would give me 18u to the fourth, or u squared. Minus 29u plus 3 equals 0. So then you can factor and we can do that. But I have even more stuff to delight you with. How to deal with the radicals. Radicals, even doing 3 problems is gonna take me longer than I want, but we're gonna do it. So the idea here in general, the big idea for radicals. If I have like some stuff where I've got like F is, this might be a bunch of stuff on a bunch of stuff. And I got G over here. Anything that solves this. Also solves F to the n equals G to the n. So I can have it at a higher exponent and they'll still have a solution. So sometimes F equals G is hard to solve. But F to the n equals G to the n isn't. It isn't hard to solve. Now, it's been what, fucking 5 days since our last time we saw each other. It's been a while. I'll have, if you remember, at one point I said the largest exponent in your equation tells you the number of possible solutions. So if I have like a bigger exponent is gonna have bigger solutions. Or more solutions. And some of them won't solve. Some of them do not solve F equals G. So. The big message here is check your solutions when you're done. Check your solutions in the original equation. EQN is a common abbreviation for equation. Let's take a look at x minus the square root of 4x plus 12. So the radical sucks. But if we square a radical, it makes the radical, the square root go away, right? So the idea here is to use the square of the square root is just the original. We don't want to do it here though, not here. If I square this, like that is really this. Oops. This is x minus square root of 4x plus 12 times x minus square root of 4x plus 12. And that doesn't help us. We're still going to have a square root in it. So the idea is you're better off get the square root alone. Then squaring it doesn't cause a problem. Doesn't cause any issues if it's isolated. Quarantine that motherfucker. Like you might be letting out a virus. You gotta throw that shit in quarantine. So we could do that just by adding it to both sides, right? If I add it to both sides, I get x equals the square root of 4x plus 12. Now we square it. I get x squared on the left. On the right, I get 4x plus 12. So I can subtract 4x and 12 from both sides. And I get x squared minus 4x minus 12 equals 0. Looks like a factor, I get x minus 6 and x plus 2. I set each equal to 0. And I solve and I get x equals 6 or x equals -2. I have two solutions, but my largest exponent in the original equation was 1. So at most, one of these works. Both of them can't work because I didn't start with an x squared. So what I'm going to do is I'm going to take that very initial equation that's off the screen right now. X minus square root of 4x plus 12 equals 0. And I'm going to test these. So if I start off with x equals 6. If I test that, I get 6 minus the square root of 4 times 6 plus 12. Does that equal 0? So this is 4 times 6 is 24. Plus 12, I got 6 minus the square root of 36. Does that equal 0?
Yeah.
Yeah, it does. We get 6 minus 6 equals 0. So x equals 6 is a good answer. Which means the other one probably is not going to be, but you should check it. You should always check every solution because sometimes none of them work. Sometimes you just find out that nothing worked. So let's try the x equals -2. And I get -2 minus the square root of 4 times -2 plus 12. Does that equal 0? That's -8 plus 12. This gets down to -2 minus the square root of 4. Does that equal 0?
Yeah.
No.
It does not.
It does not.
No, because this is
Oh
-2.
yeah,
That's
yeah, the negative.
-2. It actually equals -4, which is not 0. So this MFR doesn't work. X equals 6 is your only answer. This is called, if they ask, it's called an extraneous solution. If the homework asks you, I'm not gonna do something on the test, so. But if I didn't think you'd never hear it again, I wouldn't tell you that.
Yeah.
There's a good chance the homework will say it again, if you take the next course in sequence. I don't know if it really shows up in pre-calc B or trigonometry. Trying to think where it does. It might, it would show up in calculus. I think,
Oh, showing up here, that maybe.
yeah. All right, let's do another one. Let's make it harder. Because we like harder. We are gonna solve square root of 3x plus 1 minus the square root of x plus 4. Oh, look at this dick with 2 radicals. And he didn't even make the right side equal 0. The right side equals 1. Because he wanted to make this shit hard. So with two radicals. And an extra number with it, we're kind of screwed. We're gonna have to, like, no matter how we square it. We're not gonna get rid of all the radicals the first go around. But. Make this shit easier on yourself and separate the radicals. At least get them on different sides. So I'm gonna add square root of x plus 4 to both sides. Oh, yeah. I have square root of 3x minus 1 equals 1 plus the square root of x plus 4. We square both sides here. The left side is just a radical squared, that side's actually easy. It's the other side that isn't. This is 1 plus square root of x plus 4 times 1 plus square root of x plus 4. We can't just distribute the square to each of them. If I multiply that out, I get 1 plus square root of x plus 4 plus another square root of x plus 4 plus square root of x plus 4 squared. I'm just doing the whole FOIL thing. That times that, and then this times this, and this times this. So if I clean this up some, I've got 3x minus 1 on the left. I've got two of these radicals that say square root of x plus 4. And then I've got the 1 here, and I've got this part right here is x plus 4 after I square it. So I should have plus x plus 5. The 1 and the 4 make the 5. So I got this x came here, and then the 1 and this 4 added to make the 5. All right, now I want to get the radical by itself again. So I'm going to subtract x and 5 from both sides. Okay, so I'm going to do this the longer way just because it's not really a lot longer, but the way I would normally do it, just to show you what happens. This is both sides here are divisible by 2. And it divides by 2 pretty easily on the left side, right? If I divided the left side by 2, I would have x minus 3. That's fine. Sometimes it doesn't divide easily by 2. So if it doesn't divide easily by 2, once I get it down to just one term like this, don't divide by 2 if it makes fractions. Because the next step is squaring both sides. If I do this, if I've got a fraction over here, fraction work sucks. But if I don't have a fraction, this is just 2x minus 6 times 2x minus 6 equals, here I distribute, now I can distribute the square root of both of them, 2 squared and square root of x plus 4 squared. This is 4x² minus 24x plus 36 equals 4 times x plus 4. I'm gonna actually divide this by 4. Just to show what happens if I had done it earlier. Divide everything by 4 now. To get rid of that 4. That's what I'm doing right here, trying to get rid of that 4. I have x² minus 6x plus 9 equals x plus 4. If it generates fractions. Instead,
Sorry, I just have a question. It shouldn't be a negative 48x instead of negative 24? Or I'm wrong?
no. Negative 6 times 2 is negative 12. And negative 6, like negative 12x and negative 12x is negative 24x.
Okay. Oh yeah.
So if dividing by the 4 generates fractions, don't do it. What I would do at this point is just distribute that.
No, yeah, I was thinking. I don't know what I was thinking. No, you're
It's
right.
okay, I'm not, this has nothing to do with what you were asking. This is a side note. You can solve this still by doing this. In fact, it works here.
That's because I put a 4 instead of a 2 up.
That's fine. So that would be if like, I'm gonna work with this one. I'm gonna subtract x minus 4 and from both sides. I get x² minus 7x plus 5 equals 0. I'll show you if I do it this way, I can divide everything by 4 here. And I get x² minus 7x plus 5 equals 0. So there's more than one way to get to this value over here. If you just divide it by 2 right away, is the shortest, quickest route. Well, we get here. This doesn't factor, so we could do quadratic formula. This is fucking ugly. Yeah, you're right, okay. So A equals 1, B equals negative 7, C equals 5. X equals negative B. Plus or minus the square root. I'm doing this formula right here. Quadratic formula. B squared is negative 7 squared minus 4 times 1 times 5 all over 2 times 1. Square root of 49 minus 20 over 2. God, I feel like I fucked up somewhere. Like this is fucking ugly. I don't see any fuck ups though. So x equals 7 over 2 plus or minus the square root of 29 over 2. Ah! I did. That's why it's a shitty problem. The problem was meant to be 3x plus 1, and they would have had nice, pretty solutions. Alright, so what you do when you're gonna like one of these, this is 2 solutions. Might as well, we did the fucking shitty one, we're gonna finish the shitty one. This is x equals 7/2 plus square root of 29 over 2. And this is 7/2 minus square root of 29 over 2. So I'm gonna get a decimal version of this. Well, we gotta test it. It's shitty. This is harder than what's gonna be on the homework or the test. It should be. Ooh, what was that? Okay, so I got 2 shitty numbers. I hope this is harder than what the homework gives you. Because if the homework gives you something harder than as hard as this, they're beat dicks. Are you loving the setup, Drew? You look like you love this.
Oh, yeah, love it.
Now let's just pretend this was the whole number, like 6 and 1. The next step would be just the same. We started with square root of 3x minus 1 minus square root of x plus 4 equals 1. I'm gonna plug in this thing right here. To the left side. For my x's. So. I have 3 times 6.1, all that crap. I'm gonna do the whole thing. Minus 6.19 plus 4. What do I get here? Square root of parentheses 3 times answer minus 1. Minus square root of parentheses answer plus 4. Ah! I got a 1.
No way. I see that.
Fucking glare. It's a 1.
Oh, there's the one.
Wow, I need glasses.
But I just used the answer key, so there was no rounding, I didn't round it all. I used what was stored in the calculator. I'm gonna go back and do this one right here real quick. So x equals 7/2 minus square root of 29 over 2. I'm gonna calculate that again in the calculator real quick. That way I have the whole answer. And I'm gonna do that same setup. I'm gonna do square root. Parentheses 3 times answer minus 1. End the parentheses minus the square root. Parentheses answer plus 4. Square end the parentheses. When I plug this one in, it gets -1 equals 1. So that one doesn't work. A lot of work, but I found out this is the right answer.
That's crazy.
That's way harder than fucking, I guarantee you harder than anything on the test. You have to check your work though. So this was sucky, but it's a good learning lesson. Goddamn, it took her like 2.5 pages. Okay, we're not gonna solve it all the way through, but I want to illustrate what happens. If we have the cube root. That's funny, I was gonna say party foul too, exact words, I almost said it out loud. It's all fucking stimulated by it. About to make a no face. All right, so we would add the cube root of the -1 to the other side. What would I do next?
Multiply both to the cube.
I'm gonna cube both sides, yeah. So we would get this. That's the hard part, really. The hardest setup here is where you got, is the other one we just did where there's two radicals. It's like the hardest setup, where you got two radicals and another number, because you gotta do the squaring thing twice. This actually isn't too bad, it's just a cube rather than a square. And we would solve normally and check the answers. You know, this was a lot cleaner if I had 3x plus 1 right here. I'm certain it had like whole number answers to check.
I
Just doing a plus rather than a minus completely fucked everything up.
believe I remember you saying 3x+1, and then you wrote that down, and I wasn't sure, so I just didn't say anything. Now.
The fuck, Jimmy?
Now going back.
Now here, you could have fucking saved us a lot of extra work. Jimmy knew better and he let us go down this road. That's fucking Jimmy for you.
Hey, at least, like you said, it was a great learning.
It is, because you know why this was a great learning lesson? You got to this motherfucking answer. Even before I went to a decimal, you got to here and said, nope, that can't be right. I even did it. I said, that can't be right. I did it because I wouldn't set up a lecture like that. That's ridiculous. Takes too long to do, but it's natural to look at it and go, that can't be right. But when I wrote it as a decimal and then checked my work, it was right. It actually was. So like, just because something's ugly doesn't mean it's wrong. It is a great life lesson. Marry an ugly person, it'll make you happier than fuck. There's a song about it. Never make a pretty woman your wife. Make an ugly woman your wife, you'll be happy for the rest of your life. It's a song, it's an old song. All right, so we can do that normally, solve it, and then be sure to check your answers. What if we had something like this? Whoa, that face gonna fuck shit up right now. What if I had x to the 3 halves equals 216? How could I solve this? Rational exponents, what? What? So there's two ways to look at this. One of them takes a long while. One of them is to go, okay, this x to the 3 halves is x to the 3 times 1/2. So like the square root of x cubed. And so I could put square root of x cubed here. And this is where it gets shitty. I could square both sides, 216 squared, I don't know what it is. This is fucking tedious, gets big numbers. This is not ideal. Because then I still have a cube that I gotta deal with, right? Still have a cube to deal with. Instead. We want to end up with x to the first power here. That's the goal. Goal. I can do that if I multiply this exponent by 2/3. It's reciprocal. Multiplying 3/2 times 2/3 gets us a 1. But when we multiply exponents like that, what we're really doing is raising both sides to the 2/3 power. You could put this in a calculator. 216, arrow key. Parentheses 2 divided by 3 and parentheses. Or you can go 216 to the 1/3 times 2. This is the cube root of 216 squared. Cube root of 216, you may not know, but there's a cube root button on a calculator that's easier than this. It's 6. X equals 6 squared, so x equals 36. How would I go about doing this one? I know you guys are still writing. Oh, yeah, nice and warm. Oh, aromatic. Do not come in here. I had Taco Bell for lunch. No, I didn't. I didn't have Taco Bell for lunch. I was on Venture Brothers. The Venture Brothers. The cartoon.
Is that 3/5?
2/5.
Lazy already.
That beats walking down the hall and getting using the sharpener down there, but. You could buy one, they're probably like 99 cents or some shit like that.
Good, but
Cheap motherfucker.
I mean, they're gonna have to go get up with the power.
That's true. That's really what it is.
So
Alright, so if I wanted to do this, what could I do to address this? Five halves. So this is x plus 7. This is 4 to the 1/2 to the 5th power. So if we do it that way, this is square root of 4 to the 5th power. Which is plus or minus 2 to the 5th power. One of these isn't gonna work, I don't think, but let's check. If I raise 2 to the 5th power, it's 2, 4, 8, 16, 32. X plus 7 equals 32, or, oops. X plus 7 equals negative 32. I subtract 7 here, I get x equals 25. I subtract 7 here, I get x equals negative 39. Oops, subtract 7. I'm pretty sure the one on the left works. 25 should work. Does the negative 39 now? So I'm gonna do negative 39 plus 7 is negative 32. So I got negative 30. You at least see the keys in. There, it shows up there. Okay, you can't see it. So what I'm gonna do is I'm gonna use the exponent key. And raise it to the 2 divided by 5 power. Nope, it doesn't like it. Let's go with that one. All right, let's take a 5-minute break and then we'll get 1.7 knocked out. I'm actually gonna stop.